Great. That was intense. That's intense. Good. I'm glad to hear it. Do you guys want to start by just taking some questions? You guys have had some homework assignments that you may be at various stages of doneness on. Again, no due date until Sunday midnight, right? And I put 3 of them up there. Only 2 of them you're able to do yet. I had the 3rd one written, and we're going to do that stuff today, so I figured I was going to put it up there anyways, just to save myself the time. And there might be another one coming also today, but it depends on how much we're able to, like what we end up getting through. But so I didn't put that up yet either. But questions from anything, content, homework, specifics, not specific. Starting with, tell me your name though. Jay. Fox? Yeah. Jay, go.
When you're doing like an inequality, what func defines this?
Okay. So just as an example here, we'll do like something like this. Oops, as an inequality, sorry. Greater than or equal to. Okay, so we'd start by subtracting 10 from both sides. Adding and subtracting isn't going to cause an inequality to change. So nothing changes there. Next, we would divide by -3. When we multiply or divide by a negative, that's going to cause the inequality to flip. So the inequality flipped because of the negative that we divided by. So far, good, so good with that? Okay, then we would split this into 2 pieces. So 5 minus x less than or equal to 4. And then 5 minus x greater than or equal to -4. So when we do the negation, when we split our absolute value, that causes an inequality to flip also. And then we'd subtract 5 from both sides. Adding and subtracting things to both sides doesn't cause an inequality. And then we would divide by -1, but here we're dividing by a negative again. So that inequality symbol is going to flip again. And the last thing we would want to do is to plot these on the number line to see what's going on. So these are pointing towards each other, so that's the and situation. Alternatively, you could write it as something like that also. That would be fine to write it as. But those are really the 2 scenarios. Either you multiplying or dividing by a negative, or when you do that split, the piece that gets the negated right-hand side, also the inequality symbol flips. So I did an example there to kind of, it made it easier to talk about, basically. But you're good? Okay. Were you forgetting about the one on the split? That's an easy one to forget to do. Mayo? That's not even close. Is Maya in this class? No. Perfect. I'm an idiot. You ask so many questions and I can't get this name straight, and it really bothers me to no end. Natalie. Thank you. I'm sorry.
It's okay.
I'm not mad at you. I'm just frustrated with myself.
It's okay.
It happens all the time to you?
Yeah.
Oh, that's hard. Okay. Anyways.
My question is, can you please walk through the process of drafting inequality?
Yeah, that's what we're doing today. So we hadn't, like I put that assignment up there, we hadn't gotten to that yet. So that is what we're doing today. That's the first thing we're doing today. So we will do that. I'm going to put that on hold, though, until we finish any other questions, because that's like the lecture part for today. So rather than jumping back and forth, we'll just circle back to that. But reasonable question, because we didn't talk about it. Not reasonable that I would expect that you knew what to do with it. I just got carried away and put up more homework assignments than you were able to do. So when you got to that one, you're like, I don't know what to do with this, and stopped. That's good. That's what you should have done. Good. Mia.
When you're solving inequalities, absolute value,
Mhm.
if there's an absolute value, then you can put the value inside, and then a negative number on the other side. Would it still be no solution?
So you're adding like this, right?
Yeah.
You can say no solution there, and that would be
Okay.
fine.
I was wondering if that was only if it was equal to, because it's just one number.
Even if you have this, it's still going to be.
No, just like straight up
Oh,
equal to. 'Cause I know
yes,
that's the solution.
right.
I'm worried that because it's an inequality and there's a set of numbers, if it will be.
Yeah, so again, like this part can't be negative. If that has to be less than -1, that would certainly mean that that result would need to be negative. I would agree. You can say no solution there. And there may have even been a couple in the homework where that happens, right? Now, if it's a greater than there, no problems. But, okay, cool. Anyone else? Okay, can I ask an honest question? There's no hard feelings either way. Is the lack of questions because this was easy and you got it, or is it just we haven't started a lot of the homework yet, so we don't know that we have questions yet? It's the second for a lot of us, and that's okay. Look, it's okay. Be honest. It helps me knowing where we're at and kind of what the pattern has become, and that's okay. Like again, the due date is the due date. I made it a flexible due date because so you don't have to go home and bust your butt to have it ready for the next day. I get it. I would love for you to like give it a couple of, like do part of it at least. Like even if it's just like I'm gonna do 15 or 20 minutes of this and then I'm moving on, just so I've done some of it, because especially in preparation for the next class where we're gonna start with questions from the homework. Even if you go and jump just to the hard ones, you're like, okay, the easy ones are gonna be easy in the beginning. Like I'm just gonna pick out stuff that looks hard and try those and see if I'm super confused, I can ask about that stuff. That would be helpful to me. And shouldn't be too big of an issue to find, 15 or 20 minutes or whatever to sit down and do a little bit. I don't, like you don't need to finish it all. Some of us probably have, and that's fantastic. But it would help, I think it would help me, and I think it would help you guys for these next classes to at least have done a little bit of it. And it's okay that you haven't done any. Like I want to be clear. Like I'm not mad about it. I'm not scolding you. I'm just saying that like I think things will go better if we try to do a little bit. Even if you can't finish it all, that's okay. Okay, guys? So if nobody has anything else that they want to talk about, I am going to move forward, and that's okay. We'll probably finish early today and give you guys some time to do some work and get caught up on some of these things or get a start on some of these things for us if we haven't yet, and that's fine. Because there's really only 2 things left to talk about, and neither one of them is, based on what we've done, is super duper complicated. So it should be relatively, I think 40 minutes is probably about all I need. So, everybody okay? All right. I'm also going to tell you, I was planning on doing a homework quiz today, and after you guys answered that many of us haven't started anything on the homework, I'm going to pass on that till next week. So if you were planning on, like, when's this coming? There's usually at least one per chapter. It was planned to be today, but after you guys have told me you haven't really started the homework yet, which is fine, I'm going to kick that can down the road so that maybe I get a better result out of it. But you might expect that next week then. Okay. So on to Natalie's. I got it this time. Let's talk about graphing absolute value inequalities in two variables. So what do I mean by in two variables? I mean something like an example like this, where we have x and y. So it's something you'd be graphing on the xy axis as opposed to the number line. Is that okay with what I mean there? So when I have an inequality in two variables, it's always going to contain, I shouldn't say always. So okay. So when I graph an equation in two variables, I have an infinite number of solutions to that, right? Any pair of xy that satisfy the equation could be considered a solution. To represent that solution set, then we draw the line or the curve or whatever to represent those infinite number of solutions. So in a way of thinking about it, a graph is like a solution to an equation in two variables. Is that okay with everybody? Okay with that concept? Now, an inequality in two variables still contains an infinite number of points, but instead of needing like a curve or a line or something to represent that infinite number of solutions, we're going to have a region, like an area, that's going to represent that infinite number of solutions. Okay with that? Now the boundary for that area is going to be the line, the graph that we would draw if it was just an equal sign. And then we'll either be shading like above or below, depending on the inequality. Is that okay with everybody? Okay. So if I'm going to do a problem like this, we're going to start by just graphing y equals -2 times the absolute value of x plus 3 minus 5. So the way that we talked about doing this is we're going to start by identifying the values for a, h, and k. Is everybody okay with how I pulled those values? Okay. The place that students make the most common mistake is not remembering the h is always the opposite sign of whatever it appears. And then we're going to build our transformation map. Are we okay with how I did that? So that's just bx plus h, comma ay plus k. That same transformation map that we used last chapter. I just wrote, instead of plus and negative, I wrote a subtraction, and there's no b here, so that was just 1. And then I'm going to use the 3 key point from the parent function for an absolute value. Every time I graph any absolute value, these are the 3 points that I'm going to transform. So when I do that, I get -4, comma -7, -3, comma -5, and then -2, comma -7. Is everybody okay there? Still good? Okay. Let's do this real quick. Pop in the grid lines for me, because we're going to graph this now. So I'm going to graph these points. So I'll go by 2s since 7 is kind of a big number. So like 2, 4, 6, 8, 2, 4, 6, 8, 2, 4, 6, 2, 4, 6, oops, 8. So if I have -4, -7 is going to be like right here. -3, -5 is going to be like here. And then -2, -7 is going to be like right there. Everybody okay with what I plotted? Now I'm going to draw my graph. But before I do that, there's two types of graphs that I might draw, or two different ways I might draw this graph for an inequality. So for a strict inequality, for a greater than or for a less than, we're going to use a dashed line. A strict greater than or equal to, a greater than or equal to, or a less than or equal to, we're going to use a solid line. So in this problem, I forget already what we wrote down. It was a strict less than, so here I'm going to be using a dashed line. Everybody okay there? So far, so good. Now, the only other thing left to do is decide whether I should be shading above this or below this, right? So let's go explain to you how to do that. So the way you'd want to think about this is if we look at the original inequality, we have that y's need to be less than this value. This value is the y coordinate. So which way should I be shading if I want the y's that are smaller than the y coordinates on the line? Below, right? So for a given x, we have some point on the graph. I want all the points with that same x value, but y values that are smaller. So we're going to be shading below. Does that make sense to everybody? So we can consolidate that. So for y less than whatever, or y less than or equal to whatever, we shade below. And for y greater than whatever, or y greater than or equal to whatever, we're going to shade above. So this graph, when I do my shading, I'm just going to draw it like this. In fact, I probably should have used a different color other than red because it's now getting blurry with the dashed lines. Let me do that real quick. It's easy enough to get rid of it. Well, it's going on forever, right? So that's, yes, it's only the part like either inside the V or everything outside the V. Claire?
Would it ever be like x less than or equal to, or will always be y?
So the way that since we're describing functions, if I describe x equals whatever, it's often going to be like the V would be sideways, and it would fail to be a function. So like we're always going to have a y equals situation. You might have remembered in your Algebra 1 class doing something similar where maybe they gave you like greater than 5 or something and having to screw around with the equation to get it set up the way you wanted to before you could draw your graph, and then having to worry about flipping the inequality symbol if you had to divide by a negative or something. Won't happen here with the absolute values, but that's a reasonable question. You happy?
Yeah.
Jay?
When you're writing down the transformation table thing, one thing x, y, and then you write 2, then x plus 3, what do you use to get that?
Sure. So this map was the same map from last chapter. So that was bx plus h, ay plus k is that map. So that's something that we're going to use in every chapter that we graph a function. We're going to be using that same transformation map. And I gave it to you on the last test. My expectation here would be after chapter 2, this has become something that we have memorized. Because you'll use it enough to where it's just like, okay, like I got it. And that's about as, they really don't get any more complicated than this. This is really, they're all kind of the same. So we can do another one if you'd like, or we can move on to the next idea and finish a little earlier. Either is fine with me. You tell me what you need, I'm happy to comply. Sure. Okay. So we're just going to pretend this is a y equals and compute the points for the line. To do that, I need to identify the values for a, h, and k. What would my value for a be here? -1, very good. And my value for h? +1, very good. And the value for k is 6. Everybody cool with how we came up with those numbers? Okay. So then we'll create our map, our transformation map. So bx plus h, ay plus k. Everybody happy with how I came up with that? We're going to transform the same 3 points. Every absolute value graph that we're going to draw, we're going to use these same 3 points from the parent function to do the transformation. So that gives me these 3 new transformed points. Any question how we came up with those? Maddie? Correct. Yep. The negative of 0 is just 0. Exactly right. So far, so good? Okay. So let's plot these then. I'm just going to draw, like one part of the xy axis because I don't need the rest of it. 1, 2, 3, 4, 5, 6. And 1, 2, 3. That was more than I needed, but that's okay. So I have 0, 5, 1, 6, and then 2, 5. Should I draw this as a solid line or a dashed line?
Solid.
Solid, very good. And we know it's going to be solid because it's a or equal to inequality. Okay. And then should we be shading above or below?
Above.
Good. This way. So that's going to be above. So there's my graph. Basically the same process as graphing the function. You just have two extra things, deciding if the line should be solid or dashed, and whether we should be shading above or below. But otherwise, it's the same process. Do we feel cool? Okay. So this was a good one to do, because if you haven't done the graphing yet, this also helps you, serves as a good example for the graphing, because it's basically the same process plus two little extra things at the end. But if you can do this, you can do the graphing, right? Okay. The last skill that we need to talk about for this chapter is this idea of modeling. So modeling, we want to go for, the idea here is we're going to go, maybe I should put idea there. The idea is we're going to go from a graph or information about a graph to an equation. There we go. So let's do an example and kind of talk through how to do this. So let's say we're given this graph, and we're asked to write the absolute value function that represents this graph. Okay with this plan? To do this question, I need two things. I need the vertex and any other point. Okay with that? The vertex is the point on our V. So if I read the coordinates here, that looks like that's the point 4, -6. Everybody okay there? For my second point, it doesn't matter what point you pick. I mean, I'm going to pick something where it's easy to identify what the coordinates are. So like one of the intercepts is usually a good choice. Or if you can find something at like whole number points. So I'm just going to pick 0, 2, because I can see what that is immediately. I don't have to like try to trace down and figure out what the coordinates are, since nothing is labeled for me. If they labeled something, I would just use whatever the labeled point is. If they labeled more than one point for me, I wouldn't care which one I picked. They're all going to work. Everybody's okay with this? Okay, so here's the trick. Is I want to be able to write an absolute value function. I want something that looks like this, right? So I need to figure out a value for A, for H, and for K. That's what I'm trying to, that should be what my final answer looks like. Everybody's okay there? My first observation is that I remember from yesterday, nope, the day before, is that the vertex is always at the point h comma k. So immediately I can tell that my h is -4 and my k is -6. Right away, just by reading the coordinates off the vertex. That should be really easy, right? Wonderful. Is it all this easy? Well, it's not that much harder, but it's not quite that easy to get the a. So if I plug those in, now what we can say is that g of x is equal to +4. That's what we have now, right? Everybody's cool with how I came up with that? What we still haven't used is this other point. X comma g of x, right? So if I plug those in, I now have an equation with just one variable in it. That I can solve for a. So if I add the 6 to both sides and simplify the absolute value, I have that 8 is equal to 4a, or that just a is equal to 2. Is everybody okay there? So if I use all three of these together and plug them into here, Ben?
Sorry, I was
Nope,
looking at
Joe.
my notes while you were saying that.
That's
You
okay.
said that's probably more like the last one with that penny point.
Yeah. So using any other point in the graph, the point that we used was this 0, -2, just because it was easy to identify the coordinates because it was one of the intercepts. I plugged in this point 0, 2 is like an x comma g of x. So I plug 2 in for g of x, and I plug 0 in for x. And now I have the a that I can solve for by itself in an equation. So I added the 6 to both sides to get the 8. And I simplified the absolute value to get the 4. If I divide both sides by 4, then I have a is equal to 2. So now I have my a, h, and k. So plugging them in gives me my final result. What does this feel similar to? Remember in Algebra 1, where you had to write the equation for a line from like 2 points? Where you compute the slope, and then you plug one of the 2 points back in to solve for the y-intercept, and then you rewrite the equation, right? Same idea here. There's no slope per se because it's not a line. It's this absolute value. But we use one of the points to generate the h and k, and to find the last quantity, to find the a, we plug the other point in and solve for a. Very similar to what we did in Algebra 1, where we wrote the equation for a line. So this process hopefully looks somewhat familiar, right? Or feels somewhat familiar. It's the same skill, right? You're modeling in both cases. The difference is that one is a linear function, one is an absolute value function. So like the mechanics change a little bit, but it's the same idea. Let's do another. Sound good? Do you want to try to do one by yourself, and then we'll talk about it afterwards? How does that sound? That could be good, right? let's do those, because that'll be helpful. Let's scroll that down. So here's the new problem. I put grid lines on this one because the intercept wasn't a whole number, so I figured it would be helpful to have the grid lines in because I don't really expect you to be able to, from your seat in the back, be able to trace over and figure out exactly what a point would be without the grid line there. You know what I mean? So I put the grid lines in. It kind of makes it hard to read in a way, but it should help figuring out a good point to use. Should make that a little easier. Joe.
So the any point, you just use like your one of your examples
Because the coordinates were whole numbers, and it was easy to figure out what they
so
were.
it doesn't have to be on like the axis.
It does not have to be an intercept by any means. No. In fact, in this one, I wouldn't use the y-intercept because it's not a whole number coordinate. And I don't know, I have to know exactly what the coordinate is. I can't like estimate it and have this work. I have to have like something where I know it's, you know, a whole numbered coordinate. So in this case, you would need something that's on a grid line or the intersection of a grid line. So I'll give you guys, whatever, some minutes to work on this. Then we'll go through it as a group. Keep in mind that your work and the work that I do might vary a little bit depending on your choice of a point. But that's okay. If you get the same final answer as mine, you surely did it correctly. Should we go through this, or do you want a couple more minutes? Either is fine with me. I'm just asking. Looking around, it looks like a couple more minutes. Okay. Sometimes it's hard to tell how much people are working, or if they're just paused and thinking about something, or where they're at. That's why I stopped and asked. Either is okay. So those of you that are finished, I've written down the correct answer there at the top. If you wanted to check that, those of you that are still working, that's fine. But I figured if people are done and they made an oopsie daisy, at least if I tell them what the final answer is supposed to be, they can go back and look for their oopsie daisy while we're kind of waiting for everybody to have a chance to try this a little bit. Okay. So to do this, I'm going to start by identifying the vertex, which I can see is the point -1, -3. That's hard to see for you guys. Let's write it on the side. So that tells me the h is -1 and the k is -3. Everybody okay there? Now I'm going to search for a point. I'm going to search along this arm of my graph, because most of the points over there are positive, or at least the x-coordinates are positive. That's one less negative sign to goof up. But it doesn't really matter. You could look on the other arm also. So I'm going to look for something at a grid line, or where it meets the intersection of some grid lines. So like that would be a reasonable point to pick. That one would be reasonable, or that one would be reasonable on this arm. Since they're happening at exact grid lines, I can estimate exactly what that, or I should be able to determine exactly what that point is. So this one would have been 1/2 -5. This one would have been 2 -7. And that one would have been 3.5 -9. Any of those would have been reasonable. Now, given my choice, I'm going to pick this one with no fractions in it, because why would I want to deal with extra fractions if I have my choice not to deal with them? Not that they're hard to deal with, but it's like one extra thing not to have to worry about. It's certainly easier without fractions. Everybody okay there? Again, did it matter which one of those 3 points I picked? No. Could have you picked points from the other arm? Sure. That just was my thought. So plugging in, I have -7 equals a times 2 plus 1 minus 3. So when I add 3 to both sides, I have -4 is equal to 2 plus 1 is 3. The absolute value of 3 is 3. And then I divide by 3 to get a. So I'd say my final answer is y equals -4/3 x plus 1 minus 3. Notice I combined a few steps here that we did separately in the first example. The first example, I tried to be really explicit, spelling out exactly what I was using to write things down and where things were going. Here, because I know what I'm doing, I kind of squished everything together into one real step, because I don't really need to plug in the h and k and then plug in the x and y afterwards. I can just plug them all together in at the same step. There, Joe?
So you're not going to be a b?
Correct. For absolute values? Yeah, one of the things we did last time was we established how that with an absolute value equation, if you include a b, we can simplify that like this. And that b can always be can just turn into an a, basically. So anything that I can describe as a horizontal stretch or shrink, I can also describe as a vertical stretch or shrink. So I don't need to worry about the b's ever. I can write everything as an a, which simplifies everything down for us. Is that okay? Okay. So when we're graphing or modeling or any of these things, I'm never going to worry about a B because I can just use an A instead. Is everybody okay there? Let's do one more example of this where I use some words instead of giving you the drawing. Okay? Is this problem any different than the one that we just did where I give you the graph? No. That's a 2. So draw my 7s, I try to draw them with a bar through the middle because they do end up looking a little bit like my 2s. And my 2s look a lot like my z's, so the z's I put a bar through the middle. So you can tell the difference between a 2 and a z, because without the bar, God help me, most of the time you couldn't tell the difference. I can't tell the difference half the time when it's my own writing. So these are all life hacks you learn as somebody that presents material to other people on a daily basis and has to cope with their own crummy penmanship. It's like, what can I do to make this more clear? Okay. So the only difference between this problem and the previous one is we don't get our choice of what that other point is going to be, right? We have only one option. It's the one that's provided to us, and we're stuck using it. But that's okay. The only crummy part is that this other point is a stupid fraction. So I can't really avoid having a bunch of fractions rattling around in my problem, right? But that's fine. We can deal with fractions. So we'll start by adding 5 to both sides. To add 5 to 11/10, we need to make a common denominator of 10. So that's going to be 50 over 10. Subtract 2 from 3/7. Again, we'll make a common denominator. That common denominator would be 7. So we have 61 over 10 is equal to the 11 over 7 times A. Now 3 minus 14 is negative 11. So the absolute value is going to be positive 11 over 7. And then we'll just multiply the reciprocal to both sides. So 7 times 61 is 427. And 11 times 10 is 110. And we have this really gross looking fraction for A, but that's okay. Like, it wasn't too bad to get to. Like, hey, it's just fractions, guys. You know? We can handle it. Was that minus 5? What's a minus 5? But like, that's the worst it would get or can get, because I have to give you this gross, like, would have to just make the numbers inconvenient to deal with. Did the process get any harder? No, just the numbers got inconvenient. Probably not. Let me think. Is it reasonable that you guys could do one of these without being given the vertex? Let's just see. I'm not sure how this is going to work out, so I'm going to put like a question mark next to this example. Okay. I'm not sure if this is going to be doable for us or not. We're just going to kind of take a stab at it. I have an idea of what we would do to see if this will work, but I'm not entirely positive if we have all the tools that we would need to do something like this right now or not. So we're just going to kind of play. 3 points should be enough though, right? So what I'm going to do is this is what I need, right? Is this equation. Basically, I need to find 3 variables. I need to solve for an a, an h, and a k. Everybody okay with that idea? So what I'm going to do is I'm going to create a system of 3 equations. So using the first point, I have -9 equals a times -5.5 minus h plus k. Using the next point, I have -5 is equal to a times 0.5 minus h plus k. And using the last point, I have -7 is equal to a times 2 minus h plus k. If this doesn't work, I have another idea on what I would do here. Yeah, this is going to be a problem, isn't it? So this is bad. So this won't work. New approach. I thought maybe that would work. It turns out it probably won't. So I'm just going to sketch a quick little picture. I have something like this, right? If I plotted those 3 points. Now I didn't actually make any coordinates on here. I just kind of generally threw them on there just to get an idea of what it looks like. What I noticed though is that these 2 have to lie on the same line. Everybody agree with that? Because they are right here. The only way for this to look would be something where it's like that, right? I can't get, if I tried to do something like this, I can't get all 3 of them on the same V. Do you guys kind of see what I'm pointing out there? So let's write the equation for this line. Let's try doing that. So that line would be calculating the slope, -7 minus +5 over 2 minus 0.5. So that's going to give me -2 over 3 over 2. Or actually, I don't know. Yeah, let's leave it as 3 over 2. And then this is the quotient of 2 fractions. So to divide 2 fractions, we make a reciprocal and multiply. So the slope there for that line should be 4/3. Everybody okay there? Okay. So if I take my y equals mx plus b, I know what m is, and I can find b by plugging in one of the 2 points. So like -7 is equal to -4/3 times 2 plus b. So that's going to give me -7 equals -8/3 plus b. If I add 8/3 to both sides, That's going to be negative 21 over 3 plus 8/3 equals B. 13/3 is B. Okay with that. So I can say something about this line here, right? That part of my absolute value. What can I say about this part of this absolute value? Oh, I shouldn't say that. They should have opposite slopes, right? If this one is going up at 2, this one should that be? Yeah, that's right. So what I can do then is if I take this point, I can go 4 units or 3 units to the right and 4 units up and find another point on that line, right? So if I take that negative 5.5, excuse me, I can go 3 units to the right and 4 units up, and I'm going to get another point that is on my line, or I should get another point that's on my line. Everybody agree with that? So now I can find the y-intercept there. Actually, I don't even need that, do I? So just in green, I didn't need to do that. It's fine, it's true, but we don't need it. This is fun, guys. Seems like you're enjoying this, watching me kind of doodly-do about this. So for the green line, we have 4/3. We'll plug in the y, x and y, and find the y-intercept over here. So I'll rewrite that as 11 over 2 instead of 5 over 5 since I have the fraction, or 5.5 since I have the fraction there. So when I add that over, I have negative 54 over 6. So that simplifies down to negative 5/3. So I have y equals 4/3 x minus 5/3. Okay, there. And now here's the payoff. What is this point going to be where the two lines intersect? The vertex. So now I'll just find the intersection of these two lines, and I'll have the vertex, and now I can go approach this as we would the previous examples. I just had to do a lot of work to get the vertex, right? It's a little bit more clear here what I would do, having thought about it now and stumbled my way through it with you guys. But it was fun, right? Let's find that intersection real quick. Would I ask you guys to be able to do this again for me? No. No, this is just fun. Right? Oops. If I add that over, I have 8/3. So there, x should be negative 1. Is it clear how I got this? Okay. And now that I know what x is, I can take either one of these two, it doesn't matter, and plug that in to get that. So my vertex is, and if you were observant, you would notice this is the same problem that we did earlier. The very first example I gave, this is the same thing. So there's my H, there's my K, and yada, yada, yada. I end up with y equals negative 4/3 absolute value of x plus 1 minus 3. Ha! It was doable. I thought that it would be. I wasn't sure how it would, what was going to be the best way to do it. I thought originally we could just solve a system with 3 variables. The absolute values kind of got in the way there. But we were able to still kind of figure it out. That was fun. I didn't know if we'd be able to do it. So that was it for this chapter. Those are all the things that I need you to be able to do. So we should be able to do the part 2 graphing, right? And did we really use that much time here? My goodness. I'm sorry. I thought I was really going to be done much, well, I was really done much sooner. It was this one last problem that really took it forever. I'll post here by the end of the day a modeling one. It'll just be like 3 or 4 questions similar to what these graphing ones are. It won't be tremendously long. I think that's plenty to get the hang of things.